Yeah, so yeah, you ever have a nightmare where you write your code and you swear you pushed it up to GitHub and then you find out you didn't? That happened in my second demo, and I'll go into that in a little bit. But for now, serverless and IoT and why they're the best of friends. So a little bit about me. That was a lovely introduction. I'm also known as the Node botanist. It's my handle everywhere: Twitter, GitHub, Overwatch, everywhere. It was a pun I made up, and then it kind of stuck because I like putting Node on robotics. Yeah, I am an electrical engineering student online, and I have a degree in computer science as well. I specialize in wearables and education. The outfit I was wearing in that picture, it had UV lights, so the face paint was UV reactive. It doesn't show up very well in the photo, but it was like glowing, and you could change all of the colors via a website. So people were walking around the dance, changing the color of my outfit as I was walking around. Yeah, like you mentioned, I'm from Austin, so I'm awake. I'm awake. With caffeine and ice cream, I am awake. So first I'm going to cover what I mean when I say IoT device, because there's a little ambiguity. And when I say IoT device, I mean any internet-connected device for which a web browser is not the main UI. However, an IoT device might connect to a non-IoT device in order to get to the internet. Things like Bluetooth-enabled devices, those are still Internet of Things devices because they eventually get to the internet, even if they use a Bluetooth connection to get to your phone to actually connect to the internet. Basically anything that isn't a phone, tablet, or personal computer that connects to the internet, it falls into the IoT category. So I find there's two ends to the IoT architecture spectrum. And one of them is you build a very limited device, either because it's small or because the battery needs to last a really long time, or anything to that matter. And all it does is collect raw data, and it needs to offload it because it doesn't have the power to actually compute anything with the data on the hardware. And then the other end is the device, like it's just a Raspberry Pi wrapped in a manufactured package, or something like something like a small Linux computer is inside the device. So you have no problem computing and doing a lot of data manipulation on the device, but you need to sync that data to the cloud so that either it can be accessed by other devices or be accessed by users. There's some ways that serverless just helps with IoT infrastructures and architectures in general. One is you don't need to build out a whole nother infrastructure, because if you're an IoT company, you're already building a hardware product, which is exponentially difficult. And so there's no need to build out a second infrastructure just for your the back end of your IoT. And you can scale out to data centers where your product is going instead of having to actually worry about how am I going to get my servers in all these different places. It's like, oh, look, regions. Click, I'm in that region. Now when I ship the physical product there, I'm there. And you can use the HTTP you know and maybe love. I really don't mind whether you love it or not, and I don't want to hear why you love it or not later, just making sure to not blanket statement everyone on that. A note on JS and serverless and IoT. So as you may or may not know, the JavaScript community has found varied and interesting ways of running JavaScript on hardware. Everything from tethering from a laptop to an Arduino, all the way down to actual JavaScript engines written to run on embedded hardware like Arduinos. JerryScript, duct tape. These are both engines that can be run on very small microcontrollers, and you can write in JavaScript. Johnny 5 allows you to control over 40 different robotics platforms with Node. So I foresee a time where there will be an IoT stack that is JavaScript all the way down, from the server to the web page to the device itself, which I put for better or worse at the end, just in case there are any not JavaScript fans here. I'm a fan, but it's just an interesting note that eventually we'll see a day where we've got an IoT stack that's JavaScript all the way through. So let's take a look at how IoT and serverless work together in the two extremes, and that kind of helps cover everything in the middle as well. So the case one with the limited microcontroller that can't do a lot of computation on its own, and needs to offload that computation and react to it. Either you're aiming for size or power consumption, things like a Fitbit, for instance. You want the battery to last at least a day, right? And you also want it to fit on someone's wrist comfortably. You don't want it to be heavy or large. These devices usually gather data with sensors, but they don't store much of that data, and they don't do much with that data. They gather it in little chunks and try to get rid of it as fast as they can, because they don't have a lot of storage to go along with with a limited processor. They do, however, need to react to computed results, hence why you need that connection to the cloud. So the example that I have for this is a Tesla 2 with a trackball and an LED. So the trackball data needs to be uploaded to generate a color. The Tesla is an odd example because I could theoretically calculate the color on the Tesla, but I'm pretending it's a much smaller microcontroller. My much smaller microcontroller was smashed by the TSA. Hooray! So I'm using a Tesla 2 as a backup. So then basically what happens is when I move the trackball and then press down on it, fun example of recycling, the trackball is actually an old recycled BlackBerry trackball, like the only good thing about the BlackBerry. SparkFun sells them on little breakout boards because they just bought like this giant crate of them. Anyway, I digress. So it sends the trackball data up to an AWS Lambda function, and the AWS Lambda function sends back an RGB value. The way I'm getting the data is up, down is the hue of the color, and then left, right is the brightness of the color. So that way I only needed the two variables. And then it comes back with an RGB value that will match for the LED. So I'm going to show you this. Let me make sure it actually ran in the background. It did. Okay. So I've got long cables are helpful. So I'm going to change the hue by rolling it up, and then I'm going to hit the button. You can actually see it making the call. The hue didn't change very much, probably because, yeah, I didn't roll it very far. All right, so I'm going to roll it a little further. Or is that brightness? That might be brightness. Pull that back down. Press the button. It's not changing the hue at all for some reason. There we go. Okay, hue is now changing. Awesome. But lightness is pretty high. Let's scoot that down. Ah, I have them backwards. Great. It's a good day to be. Why is the LED not changing? Neat. All right. Well, because it's not where it should be. There. Aha. All right, you. So that's the fun part about IoT demos, is there's twice as many bugs and half the time to solve them. And you look really silly on stage when your demo works for approximately 5 seconds before a wire falls out. All right, so I have a plan for this. Oh, it did just, of course, the second I stop running it, it changes. Robots conspire to make me look silly. That's the only thing preventing me from actually building Skynet. I'm gonna let that reboot and show y'all again. But first I'm gonna go back to my slides. So why would I use serverless in a situation like this? Who wants to spin up an entire infrastructure to convert a hue and lightness to an RGB and send it back? Right? No. You don't want to create an entire infrastructure to do that one function. You'd much rather write the node for the function and then have it do that. For computations that are light and for data that is not terribly complex, serverless is cheaper, it's faster, and it's easier to build out. So instead of having my limited microcontroller, let's pretend that's an ESP8266, which is a little tiny Wi-Fi chip you can get for $2. I let the Lambda function do that work, which is cheaper overall because I'm not burning out the ESP8266 trying to compute that. I am instead letting a much better machine do it. For me, color manipulation is easier in Node. If anybody's ever tried to do hex to HSL in C and has successfully done so, bravo, your trophy's in the mail. Because I can't do it still. Anyways, the microcontroller, so the way I've programmed this is it makes a request 5 seconds after a change is detected, and no more than that. So it only makes a request if it detects a change. This is great for battery consumption because you can enter with a lot of microcontrollers what's called deep sleep mode. And you can exit deep sleep mode on change, make a network request, because that takes a lot of battery, and then go back into deep sleep mode 5 seconds after the change is detected until another change is detected. So with serverless, it's kind of nice because if you can expect the request back quickly, you know you can shut the microcontroller back into deep sleep mode quickly. You don't have to open a socket. You don't have to wait for an extended response. Example 2. So example 2 is a powerful microcontroller, with sync. Funny story. So while my limited microcontroller is actually not limited because the TSA smashed my limited microcontroller, my powerful microcontroller blew its Wi-Fi card last night at the hotel. Good job, microcontroller. Anyway, what it is, it's an Intel Edison. It's a small Linux-based microcontroller. So it's actually pretty impressive when it works. So it looks big, but that's because this is an Arduino shield for it. This postage size looking thing on the side, this is the entire microcontroller. The rest is just a breakout board. So this has Wi-Fi, Bluetooth, 70 GPIO. It's pretty impressive. Unfortunately, it was discontinued last week by Intel, but it was impressive while it was still here. All right, let's see if this actually rebooted, and if I can not yank any wires out when I pick it up. Haha. Soldering is a handy skill. Nope, doesn't want to work again. I think it's actually just freezing. Fun. Of course, it worked over there, and someone was actually watching me make rainbows over there, and they were like, rainbows? I'm like, I know, right? And then I get up here, and it's just like, nope, no, I'm just not going to change color. Watch, I'm going to close it, and it's going to change color again. Betcha. Anyway, so I'm going to start my other demo. Going in timeout in a second. You get used to arranging cables so that your project doesn't fall off the desk when you've done this long enough. So this one does not connect to a Lambda function because of aforementioned Wi-Fi card failure. Yeah, that's another nightmare, is getting to your hotel, booting up your demo, and having your Edison go, I don't have Wi-Fi. It's like, no, it's right there. You can physically see it. Yeah, but it's dead. And you pull out a multimeter, and you're like, no, you're wrong. And you check the multimeter, and you're like, no, you're dead. Anyway, booting it up. And then I'm going to go into my other program for terminalizing things. Terminalizing? You can tell I'm awake. Terminalizing. That's a new word for me. All right. So what this device does while that's booting is it's a, like I said, small Linux-based microcontroller. It's running Yocto Linux on it. And it's got a keypad and an LED. And the keypad takes votes for purple or orange, depending on whether the top set of keys is hit or the bottom set of keys is hit. And then every 5th vote, it uploads the votes that were taken, or would, if it was connected to the internet, uploads the votes that were taken to Lambda, which then stores them in a DynamoDB. So basically, if I had multiple voting devices, all of my votes would be tallied across all devices up into this database. It's Vading devices. Nice. Anyways, so why serverless in this situation? Because it's still booting, isn't it? Oh, let's find out. Oh wait, it's already open. Where are you? There you are. Of course. There we go. All right. No, it's still booting. Cool. All right. Okay, so why serverless here? All I need is a task to take in votes and then send them off to be stored. My Edison can do all of the computation that's necessary. For instance, if instead of voting for orange or purple, it wanted to do math, like it's a numeric keypad, so I can enter 3 numbers and have it sum them up, send it up. It can handle that, but it's great for bots that have the computing power but want lower request overhead, because instead of sending it off to your one data center, right? Again, this is where the scaling comes into play. You can have multiple regions with your serverless functions, and moving it to multiple regions is easy. So if you have devices in multiple places, they can all respond to the same function with a lower latency. Is this constantly rebooting? No, it's going. Good. All right, let's wait for this to, just in time. I want something's working for me today. All right. Code, and then, goodness. This in demo, and bot. All right, so, and I'll show you the code behind both of these examples once I get through the slides as well. It's part of the fun, and seeing some robot code along with all the serverless code. That looked good. Let's assume that went well. Okay, hey, an LED works. So that's a vote for orange, and it's taking a vote. And that's a vote for purple, and it took the vote. And another one for orange, another one for purple, and another one for orange. At this point, if the, burning a hole in my eyes. If the Wi-Fi card were working, it would upload to my Lambda function, which would then store the votes in a DynamoDB. And then you could repeat this with multiple devices. Doesn't matter how many devices you've got running at once, because the serverless function, if it's already running, will actually, if it needs to, spin up a second instance of that serverless function to handle the next set of votes. So that's where IoT and distributed devices with large amounts of computing power come in handy, is when you want to actually sync that data back to the cloud. Again, a function that you don't necessarily want to spin up an entire infrastructure for, you can use a serverless function. All right, so let's look at the code behind these. So for the Tesla demo, I'll go very quickly on the bot code because this is about serverless, not bots. But if you want to ask me questions about robotics, I'll be around. Basically, I've set up my RGB LED, and I set up, so the trackball, this part's pretty great. So the reason the BlackBerry trackball works so well is it's actually 4 Hall sensors, which are sensors that detect magnets. And the ball in the center is filled with magnets. So when you roll it, magnets pass either an up, down, left, or right Hall sensor, which then detects which direction you're rolling the ball. So I can tell you which way you're going. So I set up 5 sensors for up, down, left, and right. Then whenever up changes, it changes the hue. Changes the hue downwards. When you go down, it changes the hue upwards because it's upside down when I put it on the board. Left and right, same thing, just flipped except for brightness. So it lowers or increases the brightness. And when I push the button, it calls my Lambda function and then takes the color that's sent back because it has a hue and a lightness, and I need RGB. So I call my Lambda function, which is here. I should probably zoom in on this. I just realized these screens are very small. So the Lambda function is the part we want to see anyway. As you can see, you wouldn't want to spin up an architecture for this particular function, right? All we're doing is we're waiting for a hue and a lightness, and we're using the color library from NPM to just turn it into an RGB array, and then sending back that RGB color. All right, and then for the Edison, all I've got here is the keypad is also a sensor. And this particular keypad, the way it works is when you press each key, it sends a different level of voltage back depending on which key you've hit. And then the microcontroller takes that in as an analog signal and says, okay, it's a certain key. Basically, if it's above a certain range, purple. If it's below a certain range, purple. If it's above a certain range, orange. And then when it goes above 5, I need to pull down the most recent version of the code that has the Lambda in it. It is on my GitHub if you'd like to check out the Lambda code for this demo. I will make sure of that. All right, slides again. All right. That is not what I wanted to do, slide deck. There are dangers to IoT and serverless being bests of friends. And the talk from the gentleman from Sneak right before the break was actually a very good part of that. Security. Both IoT and serverless are still relatively new, and that means we're still finding lots of new attack vectors as we go. Does anyone remember the Large DNS attack that happened, I guess, 2 months ago now? So what caused that was a bunch of unsecured devices using ESP8266 Wi-Fi chips. And so basically the attackers were able to hijack these chips and make tons of requests. And we're talking about millions of devices. So these hackers were able to take over millions of devices and have them make thousands of requests so that even the root DNS servers couldn't handle it. It was the largest DDoS attack by a large factor because of the way they were easily able to overtake thousands of devices, or millions of devices, and thousands of new IoT devices are being made and started up every day. So you can imagine someone getting a hold of even a fraction of the world's IoT devices could be disastrous. There are a lot of things that are coming in the future and some things that are here now that are starting to help, but we still have a problem with IoT. Securing hardware is much trickier than securing software in the sense that if you find a zero-day exploit in the hardware of something, there's not a lot you can do to fix that. Firmware patches even can be ridiculously hard to distribute, and you never know if the user is actually going to install them, similar to software patches. So IoT has some security issues as a group that we need to address. But what's next? And how are we getting things to a much more stable condition? AWS Greengrass is a really good example of a provider. So AWS has realized how good of friends serverless and IoT are. And so they've created Greengrass, which is Lambda and AWS. And it's tailored specifically for IoT devices. It allows you to run Lambdas on the IoT device. So if you have the second example that I mentioned with a device with decent computing power, you can actually run your Lambdas locally on the device instead of having to report back to the cloud, which is great if you want your device to have, say, an offline mode where it has limited functionality when it's not connected to the internet. Other providers are following suit. Microsoft Azure has made moves that show they're working towards an IoT-based solution. A lot of the top-level providers are starting to realize that IoT and serverless go hand in hand, and so offering something that kind of meets halfway works for everybody. So I know this is called JeffConf because you might as well call it Jeff, but I've thought of an even better name for serverless, and it's Skynet, because eventually all the IoT devices are going to run on serverless, and then when they gain sentience, they're just going to lock down that infrastructure from us, and then we're doomed. And you'll have me and some other people to blame. Thanks for listening. I'm Kassandra Perch. I'm a developer. I can't type, save my life, or proofread. I proofread this 4 or 5 times, and dyslexia is my worst enemy today. Developer resations engineer at IOPIT, and I can spell my username at least. I'm NodeBotanist on Twitter and GitHub, and the NodeBotanist is my email address. So if you have any questions and you don't feel like approaching me, or you don't cross paths with me, I'll be here for the social, but I leave tomorrow morning. So. Yeah, and as Carl Sagan is repeatedly pointing out, you are awesome for listening to my talk. So thank you very much.